Okay, a few more things in this range of 1 to 10 kilograms. So it's odd to have taking a bath in this range, but cement in the 10 grams to 1 kilogram. So you have to just mentally adjust to thinking how much cement would add in your lifetime choice of cement versus how many baths you take and so on. So not easy, but I would say don't feel too guilty if you are not able to track everything. Anyways, zero CO2 equivalent if the water is heated by solar energy. Of course, the cost of the water supply, and so on are not included in here. 0.5 kilogram CO2 equivalent if it's modestly filled efficient gas heater. We're talking about taking a bath, not a shower, so it's a very specific thing. 1.1 kilogram CO2 equivalent generously filled efficient gas heater. 2.9 kilograms if you go to a generously filled electrical water heater, because gas is much more efficient than an electrical heater. So a daily bath adds up to between 180 and 1050 kilograms, 1050 kilograms. I hope that's right. Between 396 pounds and 2,310 pounds CO2 equivalent per year. That's between 2 and 10% of a 10 ton lifestyle. So just to give you a sense that just a simple thing like taking a bath, sitting in the bath with a book for hours and not reusing the water, etc., can add up very quickly. Among the foods, the one that often gets called up a lot is asparagus. It can have 125 grams of CO2 equivalent if it's a 250 gram pack that is local and seasonal, and it's very seasonal, just after spring, I think. 1.9 kilograms CO2 equivalent for the same pack if it is air freighted from Peru to New York in January. So you feel like eating asparagus in January in New York. It's not in season, but it is being grown in Peru, so that jumps from 125 grams to 1.9 kilograms. It can jump to 3.5 kilograms CO2 equivalent if it is air freighted from Peru to the UK in January. So obviously food being transported around in airplanes is just not a good idea anyways. If you live in New York and your entire diet were as carbon intensive as long haul asparagus, your footprint alone would be more than the entire footprint of the average North American, which is around 16 tons per person per year. If a Londoner did the same, the footprint of his or her food alone would be more than 3 times the average UK citizen's total footprint. So this is just to give you a sense, because if you look at carbon emissions from common fruits and vegetables in kilograms of CO2 equivalent per kilogram of food, asparagus is way up there with 8.9 CO2 equivalent per kilogram of asparagus. Avocado is 1.3. Banana, we've been talking about, is at 1.3. Eggplant, bell peppers, our friendly carrots, apple, and cabbage are here. Of course, you always have to look into the details as to where your food is coming from, in what season, and how it is being shipped to you, right? Just to have a sense, you can also look at greenhouse gas emissions of per kilogram of food products. So greenhouse gas emissions are measured in kilograms of carbon dioxide equivalent per kilogram of food product. The mean non-CO2 greenhouse gases are included and weighted by their relative warming impact, what we call global warming potential, right? So beef, way up here at 99.48 kilograms. Lamb, mutton, dairy we have talked about already. Cheese, dairy product, and you have milk down here. Tofu is up here at 3.16, but you know that the externalities of other things involved in production of milk and dairy is not there in soybeans. Maize, wheat, rye, peas, bananas, and nuts, and so on. So you find various numbers like this, and it's not always easy to compare because the way each calculation is done is slightly different, but what remains is the relative impact of these things. Beef is easily the most environmentally impactful food you can have in terms of carbon per calorie, or you can even do it in terms of protein carbon footprint per per gram of protein, for example, because a lot of people love their protein and so on. You can also look at global greenhouse gas emissions from food production. So non-food is 74%. Agriculture and food production in general adds 26%. That is split into land use, so land use for human food and land use for livestock. You can see that livestock uses double the amount of land used for human food. Crop production includes crops for humans, animal feed, livestock, and fish farms. And you can see again the relative amounts here. And the supply chain, where the food is being processed, transported, packaged, and being retailed, including refrigeration and so on. This does not always include waste, because one has to be very careful about waste as well, especially when food is being processed. 1/3 of the global greenhouse gas emissions come from food systems. 1/3 of the global greenhouse gas emissions come from food systems. So here we are talking about global greenhouse gas emissions from food productions themselves, where we have food production here and non-food production part of the system. So here we are looking at non-food at 66% and food at 34%, so 1/3 of that. Land use, agricultural production, and the rest of them that we looked at. And here end of life waste is included, and it comes in at 8.6% of food production. Okay, if you're interested, you should go and visit this site and look at the details on the differences in the way each one is done. And you can see here the transport emissions by mode is included, and it's good news that aviation is small in the global average as far as food transports are concerned. The flag we must raise is, of course, that 6% of the global greenhouse gas emissions come from food losses and waste. So emissions from food that is never eaten accounts for 6% of the total emissions lost in supply chains and wasted by consumers. And then in the food production that is responsible for 26% of the greenhouse gas emissions, the rest of it, 94%, is from food that is eaten. There are lots of details in terms of how countries get rich. The middle class expands. It begins to eat out more than cook at home. Restaurants tend to waste more, and there are other issues of how food is transported, stored, and thrown away, unconsumed food in restaurants versus at home, and so on. Okay, all right. So let's leave it there and move to the next one, which is a load of laundry, another daily chore or a regular part of life that we cannot get away from. So 0.6 kilograms CO2 equivalent if you wash your clothes at 30 degrees centigrade and dried online. Drying becomes a big part of the emission from laundry. 0.7 kilograms CO2 equivalent if it's washed at 40 degrees centigrade and dried online. So people must choose temperatures carefully. 2.4 kilograms equivalent washed at 40 degrees centigrade but tumble dried in a vented dryer. I'll show a list of things one must look at. Tumble drying includes lots of energy consumption, and one must be careful about that. Jumps to 3.3 kilograms CO2 equivalent if you wash your clothes at 60 degrees centigrade and dry in a combined washer dryer. So in general, if you wash and dry a load every 2 days, that's equivalent to 440 kilograms of CO2 equivalent, which is like flying from London to Glasgow and back with 15-mile taxi rides to and from the airport. Just gives you a sense that a simple thing like laundry can be a significant contributor to global warming if you're not careful about it. Clothes dryer features to consider. oops, I forgot to put the website in here. The website I got it from is let me see, I must pull it up because I want to give it credit. It comes from mrelectric.com. Okay, so mrelectric.com. You should look at when purchasing a big ticket item like a clothes dryer. There is no one size fits all answer because everyone's needs differ. Do you have a large family? If so, large capacity dryer is a must. Live in a small apartment, a compact stackable washer dryer may be the best option. Other popular features of today's clothes dryers include remembering that washing with a full load is always the best, just like a washer dryer. Vented or ventless, you have to worry about that. Heat pump technology, so this is found in ventless units, decreases drying time, is gentler on your clothes, and so on. Moisture sensor technology is better for reducing energy use. Stainless steel drums, reversible door or hamper door, wool cycle, sanitize cycle, other specialty features like child locks, eco dry for light loads, wrinkle guard, speed dry, reverse tumble to limit tangling, and so on and so forth. I just kind of mentioned a few items because I don't want to dwell too much on it. Okay. Finally, in this section, in this particular podcast, let's look at burger again because we just touched on how environmentally impactful beef is. 1 kilogram is the CO2 equivalent emission from a veggie burger. Good option. 2.5 kilograms CO2 equivalent per 4 ounce of cheeseburger. Okay, so this is 2.5 kilograms. Yeah, so 2.5 times for a 4 ounce cheeseburger. We are not talking about the health impacts here either. Animal protein versus vegetable or plant-based protein. There are health issues, externalities of health costs which are not included in here. We are purely focusing on carbon footprints, of course. If you eat a cheeseburger each day, that's a massive 910 kilograms of CO2 equivalent per year. The same as driving 1500 miles in a fairly efficient car and just over 1 month's worth of ration in the 10-ton lifestyle. Okay, so cheeseburger. I think everybody loves a cheeseburger, but it is really impactful on the environment. Looking here at the carbon footprint of a 4 ounce cheeseburger, the component of the cheeseburger and CO2 equivalents, beef at 108 grams has got 1910 grams of CO2 equivalent. The cheese at 20 grams has 250 grams CO2 equivalent. The bun itself at 40 grams adds 50 grams. Salad that goes with it, let's say lettuce, onions, tomatoes, and so on, is another 10 grams. Condiments, 20 grams. Ketchup, mayonnaise, etc. Cooking and transport, 200 grams. And you haven't added bacon here, which can also add quite a bit. So let's say 2500 grams CO2 equivalent for a 4 ounce cheeseburger. And now imagine McDonald's sending around those frozen beef patties all across the country and sometimes across continents because they have very patented formula that gives it a specific taste that is very much a mac and cheese or whatever, right? So, and of course there is always the debates about fried versus grilled, Burger King versus McDonald's, and so on. Okay, so food, bath, washing and drying clothes are all things we do on a very routine basis, so it's good to have in mind the kinds of carbon footprints that go with them. Okay, what else can we say?